Hello, I'm Daniel Davis. I'm a PhD candidate in kinesiology, and today I'll be talking about my study on the function of the foot's arch and gait and its relation to ankle joint function. Recently, authors have started to use mechanical analogs like motors, springs, and brakes to characterize the mechanical function of the human lower limb joints. Doing so can provide an improved understanding of how to design biomimetic prostheses, or those which aim to mimic the function of these biological joints. And also, these analyses can improve our understanding of the function of biological structures such as muscles, tendons, and ligaments which cross these joints. However, many of these analyses have treated the complexity of the foot similar to how that running icon has treated the foot. They've ignored it. An improper modeling of the foot has been shown to alter the mechanical conclusions drawn about the knee and the ankle joint. Further, the arch of the foot has been demonstrated to be capable of producing energy like a motor, dissipating energy like a brake, and storing and returning energy like a spring. Therefore, proper modeling of the foot is important not only for an improved understanding of locomotor mechanics, but also to aid in the design of these prostheses or to rehabilitate gait impairments which have classically been attributed to other lower limb joints. Therefore, to characterize the mechanical function of the foot's arch and gait, we recruited 15 young, healthy runners who completed gait trials in 3 separate conditions. In one condition, the participants walked. In another condition, the participants ran with a rear foot strike, wherein the rear of their foot was the first part of their foot to touch the ground. And in an additional condition, they ran with a non-rear foot strike, wherein some other part of their foot was the first to touch the ground. We placed small reflective markers on our participants' body segments such that we could track the position and orientation of those segments. And our participants also walked and ran across force plates, which measured the orientation and magnitude of the forces between their feet and the ground. To characterize the mechanical function of the mid-tarsal joint, or the arch, I developed the brake spring motor index, which considers the net work, positive work, and magnitude of negative work performed about a joint. As an example, if we were to compress a perfect spring, the amount of energy that we use to compress it would be the exact same as the amount of energy returned when the spring recoils. This would result in 0 net mechanical work and a brake spring motor index value of 0. However, if we used a motor to lift an object, we would be performing purely positive work. Therefore, the net work and positive work would be the same value, and there would be no negative work. This would result in a brake spring motor index value of 1. A similar situation could be described for something functioning purely like a brake. However, biological joints rarely function in this purely brake, spring, or motor-like manner, and therefore the brake spring motor index value is continuous between -1 and 1. So we found that the arch was more motor-like in walking and rear foot strike running compared with non-rear foot strike running. So in the graph on the left here, the y-axis represents the brake spring motor index. Each different color represents a different gait condition. Each symbol represents a given participant, and each participant across conditions is connected with a light gray line. The black horizontal bars represent statistically significant differences between conditions using paired t-tests. Because numerous muscles and tendons and passive structures cross both the ankle joint and the arch, we examined the extent to which the mechanical function of the 2 joints was linked. Here we can see a moderately strong positive correlation between the brake spring motor index applied to the ankle joint, which is on the y-axis, and the brake spring motor applied to the mid-tarsal joint, or the arch, along the x-axis. That the foot's arch was more motor-like in walking versus running, and in rear foot versus non-rear foot strike running indicates that more energy is actively being generated in these conditions compared with the amount of energy that is perhaps being stored to be returned later by passive mechanisms. This has implications for understanding the energy needs required for locomotion, and also may have implications for understanding muscle weakness and its influence. Additionally, structural connections across the ankle and the mid-tarsal joint are well documented. However, here I provide evidence that there's also a functional connection between these 2 joints. This connection has implications for the design of ankle-foot orthoses or exoskeletons, which aim to mimic the biological function of these joints, and may help with rehabilitating those with impaired gait function, and that the function of the foot's arch may be a target for rehabilitative efforts which have classically focused on just the ankle joint. Thank you.